quickly do this two different ways. Okay, let's do long division first. So if we go, we're gonna divide the denominator x plus 2 into the numerator. Now, which one of those do I have to? In which case do I not? Can I not skip any powers of x? Inside the bracket or inside the bracket? Good. So then we end up with 2x to the fourth plus 3x squared, 3x cubed, minus x squared minus x minus 6. Okay, so what's going to be our first term? How many times does the leading term outside go into the leading term inside? X goes into 2x to the fourth, 2x cubed. 2x cubed. So I'll distribute that through and get 2x to the fourth plus what? 4x cubed. And subtract, right? So those cancel as they need to, and then I get 3 minus 4 is negative 1. X cubed, bring the rest down. X goes into negative x cubed. Negative x squared, distribute. Subtract, first term cancels. Negative x squared minus negative 2x squared is positive. X squared, bring the rest down. X goes into x squared. X times, okay. Distribute the x squared plus 2x. Subtract, the x squareds cancel. Negative x minus 2x is what? Okay, good. Negative 3x minus 6. And then finally, okay, so we get negative 3, good. And let's see here, so, okay, so negative 3 times x. Let's pretend, gosh darn it, I did something I didn't want to do here. That works out perfectly. Let's do one, I'm going to change one little thing. Let's make this, just do this in your notes if you're taking notes. Let's make that an 8 instead. Okay, so that's going to be an 8. Okay, and then this is an 8. I just picked one at random. It happened to be a bad one. Okay, so then, right, so now x goes into negative 3x. Oh, we already did that, didn't we? Negative 3. Negative 3x minus 6. If I subtract, what do I end up with? 2. Negative 2, right? Negative 8 plus 6 is negative 2. Everybody agree? Okay, so then our answer up here just looks like 2x cubed minus x squared plus x minus 3 minus 2 over x plus 2, right? Are you with me? Okay. All right, let's do something else. Let's take this guy and we're going to evaluate this using synthetic substitution at the 0 of the bottom, okay? Remember, that was supposed to be an 8, okay? So we'll make our synthetic bracket. We'll do the one like they do in the textbook, how about? So we'll do this one. So what are my coefficients going to be?
2, 3, negative 1, negative 1.
Okay, and the number that's going to go in here, we're going to go ahead and take the 0 of the denominator. So x plus 2 equals 0 when x equals negative 2. So we're taking the 0 of the denominator, okay? Let's see what we get. So bring down the 2. 2 times negative 2 is? Add Negative 1 times negative 2 is 2, plus negative 1. 1. Negative 2 times negative 1 is negative 2. Add. Negative 3 times negative 2. Okay. Yeah. Oh, it's a negative 8, isn't it? There we go. Okay. And what's my remainder? Okay. I want to see, you tell me, if I go... Do you see those numbers showing up anywhere? Do you? So I'm looking at these numbers right here. Do you see these numbers? Oops. Do you see these numbers showing up anywhere in our answer that we got when we used long division? Those are the coefficients. How about that? Okay, those are the coefficients, and our remainder is in the remainder box, right? Or the value box. Okay, so how about that? So synthetic substitution is just synthetic division, right? Now, there's one caveat here, though. You can't, because think how we did this, right? We brought down the coefficients of the polynomial in the numerator, right? Like we normally would with synthetic substitution. But we took the 0 of the denominator and put it there. All right, so that means that we would have had problems if this would have been, for example, a quadratic, right? If this had been like a quadratic function on the bottom or a cubic, then we would have had more zeros than just that, and it wouldn't have worked. So synthetic division, we can use synthetic substitution to actually do division, and it's called synthetic division, but it can only work when you have linear factors in the denominator, right? It's not going to work if you have something else. If it's quadratic, or if it's bigger than linear, it won't work. So there's the one limitation. But how much easier is that than what we did on the previous page? A lot, right? I mean, it's a way simpler process to do synthetic division than it is to do long division, right? You have to do long division when you're dividing by big polynomials, but if you're dividing by polynomials that aren't very big, you don't have to, right? And what would you do if you had something like, let's say, let me just pull one of these out real quick. What if you had something like, see if you can come up with a strategy for me here. Okay, so what about something like this? Yeah, no, it's not that one. I won't do that one. I'll do something like, well, I'm just going to make one of them. Give me just a second. I'm just going to make one up here. So how about if we do... Okay, I think this will work. Let's try this. Could I use synthetic division for that one? No. I can't can't directly, but what do you notice about the denominator there? It's quadratic, but could it be easily factored? Could, right? I could write the bottom as what?
X plus 2, X minus 2.
Okay,
Less.
x minus 2, no, x, what's it gonna be? What number's multiplied to negative 2 and added negative 1? Okay, so if I were gonna divide 12 by 6, the answer's 2, right? But that's the same thing as saying 12 divided by 2 times 3, right? So I could, if I wanted to, would you agree that I could divide those two first? 12 divided by 2 is 6, right? Divided by 3 is 2. What's the moral of the story? I have two linear factors on the bottom. So couldn't I do synthetic division twice, right? I could take this polynomial and divide by x minus 2, get an answer, right? And then divide by x plus 1. See what I'm saying? Okay. If, I don't know if I wrote this one down right, if 2 is a 0 of the top, right? If it factors into the top. So in some cases you can do that. You know what, I don't think we're gonna have time to do an example like that. So that's what we'll do. I'll do that real quick on Monday, and then you can have a work day on Monday. But for now, all I want you to be able to do for now, don't worry, kind of forget what I just said. Because I need a little more time to explain that. For now, I just want you to get a little bit of practice. This is really simple. So this doesn't add much to the homework at all. That second section on 6.5, the practice 1, is just synthetic division. I mean, it's really quick. Yeah.
So for the synthetic division,
Mhm.
we got the coefficients doing that, but how do you figure out whether it's an x cubed or an x?
Oh, yeah, okay, good. So, yeah, good question. So what you do is, you know that these columns are gonna define what powers of x go with those coefficients, right? So here's how I always do this. I always work backwards, because it's kind of hard to get lots of coefficients. It's hard to or it's tricky to just think, okay, where am I starting? But you know that's the remainder, right? So you know guaranteed, if I were gonna write this answer down, that that's gonna be what's over my denominator, right? Okay, what do these other ones mean? Well, this is gonna be the constant, right? This is gonna be the coefficient of, that's gonna be the coefficient of, that's gonna be the coefficient of, if there were another one, it'd be x to the 4th, right? So what if I had a 0 up there? What would that mean? We just skip that term, right? So then this is telling me this is gonna be an x, that's gonna be a minus x squared, that's gonna be a 2x cubed, right? So you just kind of work backwards. But it's way, way quicker than doing long division. And you're much less likely to make a mistake, okay? So Monday, we'll talk about how we can harness this tool a little bit, right? Yeah, anyway, that's good for today.